Greetings, my name is Mike and welcome to the video. So let's see how we can set up a simple room database. First of all, I just wanted to show you what my app looks like. When you open it, there's a service call to fetch a list of Pokemon from a free cool API that exists. And that's literally all it does. It doesn't do anything if I click on stuff, but the problem here is that if I go out and open the app again, it does a service call again, and it's quite a big service call. There's almost 1,000 items there. So it's very inefficient and slow to do this. So I want to implement a room database to cache this stuff so that it's only fetched once and then it's instant every other time you open the app. So let's get started. First of all, as usual, is to add dependencies to your project. Now there's a few different options depending on your setup, but I'm just going to be adding the two base ones over here. So if you have Kotlin extensions and coroutines, there's one, RxJava, Guava, and then there's some test helpers as well. So just go through these and see what you would like. I'm going to be only adding the two base ones. And just a note though, if you're using Java without Kotlin, change the capped here to annotation processor. And I'm just going to go ahead and sync up, and hopefully it doesn't take too long. There we go. Now first up, we need to create a database class. And actually it's going to be abstract, and then it must extend room database. And annotate with @database. And then inside the annotation, we need to give it two different things. First, a list of entities, which is stuff we'll be storing in the database, and then a version number. Alright, let's take a look at the entity class here. So it's pretty much just a normal class, which we annotate with @entity. And then in here, we add the fields we would like to store in the database. As you can see, I've got a name field for the Pokemon already. But now I just need to go and add a primary key to uniquely identify this or each item. And then we annotate that ID field with @primaryKey, and we can also say please generate these IDs for me because I don't really want to worry about it. Cool, and then we go back to the database, and in our entities list here we add the Pokemon entity class. Cool, one last thing to set up the database is to create a DAO class, or an interface rather. In this we annotate with DAO, and it is how you interface with the database. It's how you fetch and store data in the database. So in here I'm going to add some methods, one to get all the Pokemon entities from the database, and then one to save all or insert them all. Cool, and then here we're not quite done. We have to add annotations on these methods. One will be a query, and this is where you need to know a bit of SQL to know how to fetch stuff from the database. So I'm just going to have a simple one that select everything from Pokemon entity. And you can put more advanced stuff in here if you're familiar with joins and that kind of thing. You can pretty much do any normal SQL stuff in here. Any SQLite stuff in there. And then on the insert one, I'm going to annotate with @insert, and we don't really have to do much else in there. Cool, finally we go back to our database and we add an abstract method which is going to return an instance of the DAO class. So I'm going to go ahead and do that, and then just make it return the DAO. Cool, now our database is all set up, so we need to go and actually use it. It would be a good start, right? So in my activity here, don't worry about all this code that's going on. Basically what's happening is in onCreate, I have load Pokemon, and here, do it in the background, very important. You can't do database access on the main thread, the app will crash. So please be sure to actually do the database and network calls in the background. Anyway, I'm going to try and get the items from the database here. If the items is empty, then I need to go and get it from the service, and I'm going to store it in the database, and then I'm going to go ahead and update the adapter to actually show the items. So what we actually need to do is these two methods here. How do we load from the database, and how do we save to the database? First of all, we need to get a reference to our database class that we created right at the start, and we can do that by saying room.databaseBuilder. In here we give it a context, and then we give it the class of our database, which is obviously Pokemon database, there it is. And then the last thing is a name, which is going to be the Pokemon, the name of the database file stored on the device. And finally we just say build, and then that'll return us an instance of Pokemon database, which is pretty cool. From there we can say get me the DAO, which is how we're going to be saving our Pokemon items, or retrieving them rather, and then here we can just say return DAO.getAll. Now it's going to be red though because I'm actually using a different model here. It's basically just I wanted to keep them separate, so if I change the database one, the whole app doesn't break. But I'm not sure if that's right, but it's just what I'm doing here. So I need to go and actually convert all these to Pokemon entity classes to normal Pokemon classes. So that's how our load function will look. Pretty straightforward. And then now to implement the save one, we pretty much do a similar thing here, getting a reference to the DAO. But now obviously we just say DAO.insertAll. And again, I'm going to have to do some mapping here because I'm using two different types. So I'm just going to create a new one. I can give it an ID of 0 and then it will go ahead and generate it for us. And then I just give it the name as well. There we go, pretty straightforward. So let's have a look and see if it actually works. Cool, first time run, you'll see it does a service call, cool. And then it displays all the items, cool. Now if we go out of the app and come back in, everything loads instantly because it's already in that database, so we don't have to do another service call. And that's pretty much the basics of Room actually. Obviously there's a whole lot more complex things you can do, and I intend to make follow-up videos on those things if you are interested. One more pretty important thing that I should mention actually is migrations. So basically what happens if you need to add stuff to your database in a new version of the app. Room provides a nice little mechanism for this called migrations, which I'm not going to go into now because it's probably a topic for another day, but I want to show you how to handle the simplest case. Okay, for example, I'm going to my entity here and I'm going to add a new field. Don't need to worry about what it is exactly, but the important part is I'm adding a new field. Then I must just go ahead and actually cater for this field quickly. So I actually map it correctly, and then in the database now, say this app is already published and I'm doing a new update. I'm going to change the version number. So this is a new version of the database, there's new stuff stored in it. But since I haven't added any migrations now, it doesn't know how to handle the update. So it's going to crash on startup. Let's just see that that happens. Cool, and then there we go, it crashes. Check the log. It says illegal state exception, a migration from 1 to 2 rows was required but not found. And it says please provide a migration, blah 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 blah. As you can see, it wasn't happy because we changed the database version, we added new stuff, and then it doesn't know how to handle it. Also, you'll get a very similar crash if you change the database structure but don't change the version number. It'll give you a very similar exception which tells you to increase the version number. But anyway, so now how we can simply handle this is to go ahead and when we build the database instance, we can say here .fallback to destructive migration. And I'll add it to the other one as well. This basically means that when there's a migration that happens, we need to just reset the whole database, which depending on the nature of your app could be alright or could be pretty bad. But for this one, I think it's fine. So basically when we send an update for the app, it's just going to invalidate the database and fetch them again. So let's see. There we go. And now it fetches it from the service as expected with no crash. And if I go out and come back in again, it's instant. So that's how you can basically handle migrations. I'll probably do a follow-up video on migrating specific versions and ensuring the data is persisted. But this is pretty much the basic example of a Room database. One more thing I actually really quickly want to mention as well, sorry. You can also, depending on your app needs, you can create, there's another method called InMemory Database Builder, which also takes the application and the type of the database. Cool, so if you use InMemory Database Builder instead of Database Builder, obviously it's only going to create a database that lives in memory of the app, meaning when the app dies, the database is cleared as well. Now this can actually be useful depending on the use case of your app and the nature of your data. For example, I've implemented a database like this at a bank where they aren't happy with storing like sensitive data on the disk. So then for that we can just use an in-memory database builder, meaning the database is cleared when the app dies. So just another thing to keep in mind. And another nice thing though about in-memory, a side effect is that you don't really have to add migrations, because when the app is updated, it gets killed and therefore the database dies, so you don't have to worry about migrating your data. So yeah, just a side note there, but I am going to stick with the normal on-disk database for this example. One more side note, sorry, I keep forgetting, is that it's very highly recommended to make a singleton for your database instance here, because it's expensive to constantly be constructing it with the builder. So what I've got here is very bad, and you shouldn't do exactly this. So you should implement some kind of singleton pattern probably in your database class here with like a get instance method, which you can just use throughout the app. So it's only constructed once and then just reused. So just keep that in mind. But again, this is the basic use case of how you can use Room. Yeah, so I think that's all I've got for this one actually. Hope you enjoyed and hope you learned one or two things here. Thanks for watching and cheers for now.